All right, you're all welcome to the part 2 of this video. So in the part 1, we will look at how we can model, how we can import our GA, how we can import a GA that we've done from the video, understanding your GA in 30 minutes. So we've done our model, we've looked at how you can start your column, your slab, your beams, and how you can arrange your grid, how you can rename your grid as well, how you can make your grid ghost, how you can make sure you have a simple model from, how you can do a simple structural model from your grid and all the arrangement. And in today, we'll be looking at how you can actually do your analysis. This is a part 2. So if you don't watch the part 1, please go back and watch the part 1 and also watch the video understanding your GA in 30 minutes. So here we'll just begin by doing what? Doing our analysis, okay? Be doing our analysis. So all what we've done, you can see everything we've done from the first floor, the second floor, and the third floor is what we've arrived here. So now we will be looking at how we can do what? We can model this. So if you look at what we have here in the third floor, you can see that we have the beam over here. We need to insert our beam over here, all right? So for we to introduce that, we have to introduce this beam before we can run the analysis, right? So in that vein, we'll just come over here to the third floor. Let's activate the third floor, okay? We'll make sure the third floor is activated. It's not, so just give us a break. So now on the third floor, we just want to create a beam to support it because we have a slab over here. So we want to model a slab over here so that we're going to do what? We are going to make sure we are going to the roof here gets to cover the slab, okay? The roof over here gets to cover the slab that here is not open. But if you just want to leave it open according to the design, based on the design standard, you can still do that. But in this situation, I just want to cover it so that we'll have a roof over it, okay? We'll have a roof covering this part of the building, okay? So don't leave it for rain, right? Or snow for it to take it. So in this situation now, what we need to do is just to activate one of these beams. We'll click on the beam, then we'll right click and we'll go to what? Property. So click on property. After clicking on the property, we'll do what? We'll click on this and we'll activate here and the same thing over here. So at this point, we're assuming that we're having a continuous beam over here. So we're having a continuous beam carrying this slab, okay? Carrying this slab. So the whole of this beam is resting on this. Okay, so in this beam, we're going to increase the depth so that we don't have any issue in our analysis. So we're going to increase the depth of that particular beam. We'll go to property. So we're going to increase it. So the depth of this particular one, let's see if that's 350, okay, or 375. Let's go at 375, okay? I don't want you to be more deep. Okay, so let's go with 375. So we'll do what? We'll click on update. So it's going to update it to 375. So the same thing to here, to this beam. We'll click either of these two. We'll do the same because we want to turn this to what? 225 by 375. So we'll go to the height, so 375 to be our depth. So that we're going to increase this. So we'll click on what? We'll click on OK. So you can see it as activated. Then we'll click close. Then after that, I want to activate this beam. I want to make sure that this beam is not cantilever because this is telling you that this is cantilever down to this column. Each time you see this arrow, it's telling you that there's a cantilever. So I don't want to introduce the cantilever. So I'm going to go to what? To copy and I'm going to update. I want to update it such that if you don't want to do that, then I'm going to terminate it. I'm going to take off that particular beam. Then I'm going to introduce it again. Okay, so this is perfect now. You can see. So this is to show that this particular beam is now connected to this, supporting it at this beam is now supporting at the edge. So, okay, so there's a support here. We don't need to introduce this, a cantilever carrying this beam. So that is okay, by the way. All right, so this has to be what? This has to be what? 300 because this is sitting on this beam. So this has to be bigger and we have a column to take care of that stress up there. So this is where we have a void that is going to be what? Carrying the roof. So at this point now, we are free to start running our analysis. Okay, so we are done. So start running our analysis. So for we to run analysis, what we need to do here, we just have to go to analysis. Okay, we'll go to analysis. So we have to check everything if there is any food. So since we have something like here, This is not the end. We're going to disactivate this. So it's going to be only at one end, okay? I'm going to change the hinge. Like I said in the previous video, you're going to change change the hinge. So we're going to hinge only one end of it. I will set that. So we're going to hinge only one and we'll remove this. So that's by the way. So now let's start this tutorial properly. So we're going to go out to the analysis. We'll click on the analysis. Now we have different part of the analysis. So the first analysis we're going to do is the building analysis. So we have the building analysis, we have the floor analysis, and we have the foundation analysis. This floor analysis is when you're doing your slab. If you're doing your flat slab, you can do that to design for the floor analysis. If you're doing your foundation slab footing, then you can design with foundation slab analysis, which will be covering a lot of video on that. So for now, we'll be looking at the building analysis, whereby we're going to generate all the forces that are acting on the structure, both the horizontal forces and the vertical forces that are acting on it. So it's all the forces and the load on the structure is going to now be directed down to the column, and we're going to have our axial forces down to the foundation for which to be able to design your foundation. Note, without this particular analysis, you can't design your structural component very well, and for the foundation to see it. Okay, so for that to be done, we have to click on what? We have to click on building analysis. So if you click on building analysis, you're going to when you're going to design, before you design, you have to check the material in which you're going to design. Okay, you don't just design. You have to ask yourself, what material am I designing with? We have a lot of when we look at the concrete, and we have the steel structures, because we're looking at the reinforced structures. Okay, so in the concrete, what do we want to design for? Let's say we are assuming that we are designing with what? We are designing our columns, all our columns with what? With C20, which means we are looking at the concrete grade 25. Okay, concrete grade 25, and this is the crunch strength of 30. This is what it tells you. Okay, so with that similar assumption, let's assume that we want to use that to design for our column, our slab, our beam, and everything. So we have to click on apply to all members. Okay, so it's going to apply to all members regarding the steel, because we're not designing for steel frames, right? We're designing for the concrete, right? Because this program is for both concrete structures and for both steel structures. Okay, so these are for the concrete structure. So now we now go to the reinforced concrete. So the reinforcement, when I look at the reinforced grade, so you can look at different grade of reinforcement. We have the different grade of depending on the characteristic strength of the reinforcement, right? So in today's we'll be looking at what? We'll be looking at, we don't want to do plain, I'll look at 460. So we're using 460 to design, and I'll apply to all members in different standard. You can look at, if you want to go with grade 500, it'll be better. If you want to design with the other grade of maybe 450 or 410, depending on your country code and your standard available for you to design. So you can just take the option, and you're going to do what? Now I'm going to click on edit. If you look at what we have there, if you cancel, if you look down here, we have edit. Okay, because we want to edit the size of the rebar, the diameter of the rebar. Okay, in as much as we've already specified the grade of the steel, we now have to check the size of the rebar in which you want to use to design. This is where I love this software very, very well, because it gives you that environment, that enablement for you to now pick up the desired reinforcement that you want to use to design your concrete, your column, to design your slab, to design your different element, your beams. You can specify what you want to use to design it. Okay, the sizes. So in my columns, I'll be taking, and it's very preferred for you to take minimum 16 mm for your column and for your beam. All right, so we'll be taking minimum 16 mm. This is our wall. We are not looking at wall in this condition, so we'll just look at these columns. All right, look at this. We'll leave this column and we'll focus on 16 mm, 20 mm, 25 mm. I'm not designing with 32, so I'm going to leave 32 out of this box. So I'm going to do the same thing for my beams and for my columns. For the beam and for the column, look at the column row. All right. So the column rows, I'm going to tick 15, 16. I'm going to tick 20, and I'm going to tick 25. So over here, this is where we have the beam. So I'm going to tick the same 16, 20, and 25. So here where we have the wall, I'm not designing for the wall, so I'm going to skip that. So now I'm looking at the slab. So the slab now, I just want to design for the 12 mm. All right. I want to use 12 mm to design for the slab. Why? Because this is a solid slab. It's going to be rest on the beam. Right. So I want to keep it simple. So on this, I'm not designing for my wrist slab or waffle slab, so I'm going to leave this row. So I'm going to look at the foundation. So the foundation here, I'm going to tick the 12 mm and I'm going to tick 16 mm, so that either which I can intertwine. I can also tick 10 for reason's sake. Let's look at what the design can give us. Then for the link, we'll go with 10 and we'll go with 8. So every other one, I'm going to untick them. All right. I don't want to go further than that, but you can still look at design. And if you're watching from US and maybe other countries, depending on your country code, you can go with 16 mm for the stirrups and all that. 12 mm minimum, 16 mm be very, very good. But let's keep this very simple. So we'll go with either 8 mm or 10 mm. Or in this situation, let's just leave it at 10 mm. Let's use 10 mm to design. All right, let's use 10 mm so that since we have this all the columns in system, to go with 10 mm. All right, because the diameter here will be a little bit not considerable. So just look at it. So we're going to click on OK after we might have taken our preferred concrete, okay, for this, okay, a preferred rebar that will tick. So we'll now go with click by clicking OK. So after clicking OK, we'll now go and say what? OK too, because we've already picked this and we said apply to all member the grade of steel. These are for the rebar, all right? So we'll click OK. So after clicking OK, you go to the floor. So on the floor, we'll have the same thing. I will change the grade for the same floor, or we can go with the same design to say the same one, and for that, I will say OK. And we check the link over here, the link for the foundation. That is if you're doing the foundation beam, also consider that. So we just have to change all of that. So now we're now going to do this because we've already done that. It's okay. So we just have to click that because this is for default material and this is for the foundation floors. Okay. So this is what we need to do. So after doing that, we just click on OK because we'll select all our material. So now you can now see that from either our columns and our slabs and all of this, our materials will pick the grade, concrete grade 25 with a crunch strength of 30 to design our column. Then on the reinforcement part of it, you can see the reinforcement steel grade will have 460 type 1 to design our columns, all right, to design our reinforcement for all of this. So either of the rebars we pick is going to design with this grade, either the 12, the 10 mm and all of that. You're going to use this particular grade to design for the size of those rebars. Okay, so in that we're not designing for the wing because we have a little situation here. But if you still want to consider designing for the wing, then you can activate that. But we want to keep this video as simple as that. So in the combination load, we've already activated the combination load by checking all the load perimeter. When we did our load generating, we generate all the load for the wing and for all of this that we're going to check. Okay, so for the horizontal part, and we've already get to all our vertical part for all of this. So for the rain, let's say we identify the rain, and we'll look at that. And let's say snow, we're not looking at that. I will say for the roof load, because you can see the roof load is already factor of safety is already be what they factor in here. So when you run your design, it's going to be what taken into consideration. We'll look at thermal condition, which is talked about heat. Now, depending on your country, in my country, we have a lot of heat, so I'll be considering this in my design. So I have to click on OK. So when I click OK, I click OK again. So that's by the way we've done by this. So I'm not looking at the wing. So all setting is what being considered. So we have to look at if we click on the setting now, we'll look at okay, what will be the design bearing capacity, because we're supposed to do that. We're going to do that in the foundation stage, but let's just set that now before we run our analysis. So if I go to the foundation stage, what do I have here? I have 200 kilonewton per millimeter square to be our allowable soil strength, which is the bearing capacity of the soil. But in this condition, let me say average. Let me say we are designing for about 120. Okay, let's look at 120. All right, so if you click on 120, so that's by the way. Then we'll look at how we can design for our beam. If we look at our beam design, let's look at our beam parameters. Look at our beam parameters. We're not designed for the foundation, so let's look at our detail. Let's look at the steel section. Okay, the steel section. We'll look at the links, look at the bars. Generally, you can just look at all these parameters and play with them. Okay, go to the drawing and all of this. So look at the steel drawing, look at the section. It's going to be cutting multiple sections, so I just want a particular section to be cut, okay, for different depths. All right, so that's by the way. So we'll now look at the beam. What we have, we'll now look at the steel bar link. It should print total quantity. All right, click on print total quantity, so it should print total quantity of steel. And I want to remove the eye struct. Okay, bring the eye struct and let's get information. Beam bar information. So we can say okay from here. Then we'll go back to what? To analysis. So when you go to analysis proper, you can now do what? You can now click on building analysis. So please do well to follow the procedure. This is a video. You can go back and rewatch every step by step of what I'm doing, because this is going to guide you proper. Alright, this is going to guide you proper. And please, if you watch this video up to this moment and you've not subscribed, please I want you to subscribe. This will enable the channel grow. Please just comment and share. Give us your review. Give us your thought. If there's any video you want us to do, just to, for the purpose of enlightenment, please do well to comment and give us an email on that, and we will be so kind and so honored to do that, to appreciate you. So thanks. So what we're now going to do to do on this design, so after clicking on this column, now the still member check, you can just do that. But this is just normally if you are doing your adding that. So just have to, if you're adding a still design to it, so just tick that and say column and beam. Then you can reselect bar, which means this reselect bar means if you design, because we have different numerous beam. We have 16 for the column. We have the 16, we have the 20, we have the 25. That is to say, if the column is going to design with 16 mm and the load is not sufficient, the 16 mm cannot carry the design. It has to take 20 and it has to take 25. Whichever within 20, within 16, within the range of 16, 20, and 25, which we've already specified. Anyone that is adequate should be able to read it. That's why we have to do reselect, so that we can reselect it. That's an order instruction you're given to the software. So you're going to do what? You're going to click on building design at this point. So this is the moment we are waiting for. So after you might have clicked this, you just have to wait for a while. The software is going to be loading automatically on its own without you having to do anything. Okay, so you just have to wait and see what the software gives us. So mind you, please, if you've not subscribed, want to subscribe and you want to like, please, I want you to like this video. I want us to go to like about 100 like, please. If you can have 100 like, I'll be so happy to do more and more video. Please, I need about 100 like, please. Please, just give us a like and give us a thumb up and comment on this video, please. Thanks you and thank you. I really appreciate your effort. Okay, so you can see it is already reselected. So you can see the one, it says, do you want to reassign default rebar pattern or axis? If yes, click now and whatever. Say yes. Alright, so we're going to wait because now it has finished designing the column and now it's designing for the beam. The beam always take a little bit time than the column. Alright, so you can see all the columns are already passed and these are the beam loading. Okay, these are the beam loading and the columns are already passed. Alright, so that's that. So you just have to give a wait and see what the software comes up with. It's still running its analysis. Like I said, the beam is going to take a bit time compared to the column, right? So let's just give it a little break and see what the software comes up with. So you can see it's still loading. We're still waiting for it to load. Let's see what happens. So this is about time. So after this beam, it's going to show us analysis. The analysis of the model. You can see it's doing the steel check. And do the steel check, and it's going to give us the both direction of the mass of the structure. The mass of the structure, telling us if the weight is going to be what? Actively on one side of it. So you can see we have relative story drift. This is the drifting check. Let's tell you that in both direction, in the y direction and the x direction, both the north and the east direction, that the structure, the column is adequate to carry the structure. So this is the fourth. In any situation whereby you see any of this show in a red sign, showing X red sign, please don't neglect. You have to go and check your properties. That means that you have to increase that particular section, or you have to add more columns or wall in that particular area. All right. So that's it. So if it fails in both directions, then it means you're going to add more columns in both directions. But if it's one direction, you have to look at that particular direction that is acting. Okay. So you have to increase the section of that property. All right. So you can see the building analysis completed successfully. No, total lapping time is 2 minutes and 6 seconds. So that's that. So we're done with this analysis, and now we are about to check the columns. Okay, so I have to check the columns to see what we have. So just to go back to post analysis, come to post analysis, then you click on the columns, then you're going to see that. Let's say okay, so you can see the numerous columns. All these columns tick in green is what showing you that is sufficient, that the depth is what the column is okay. So it has provided the columns. All our columns are okay, and they are designed with what 4x16. Okay, you can look at this bar diameter here. You can see 4x16 for each. So you can click on any of it and you check by going to interactive design. So you can look at it, look at 4x16 adequate. Okay, and you can look at the utility ratio 0.1. Because if the utility ratio is 1, then it means the column section is not sufficient, or the rebar in it. So we have to increase the section, or we increase the rebar. So in this, we are both okay. Alright, you can look at the shear, you can look at the link that I designed with 10 mm and is super okay. Alright, so that's by the way. So this is okay and design is novel. So click OK. So we're going to go to check on the beam. So let's click on the beam and let's see what happened in the beam. So in the same event, you can see the beams are all okay. You see. So if the beam fail, maybe it shows red, then you have to go double click and check what happened. You have to click on it and go to interactive design, or you double click. It's going to load the interactive design section to show you. And you can see all our beam is passing with what 216. 2D systems, which means 2 diameter 16 reinforcement. Okay, so some might show you 2y16 is the same thing. All right, so that's that. So this is 2 rebars for all the sections. So that's by the way. And looking at this now, in this situation now, you can see everything passing. But in some other situation, if you tend to remove this reinforcement, let's say we tend to reduce it, you can see that there will be failure. This failure must not occur. Everything here has to be what, especially in this extra area. This extra area means that this is the area that is what provided. Okay, this is the area provided. So it should be what required. Sorry, the area required. So you have to do what? Have to make sure that everything we have here is up to what does not show anything red. It has to be in color in green. Okay, to color green. Okay, so in that, have to make sure that that is okay. So in this other area, this is the what for the link spacing, and this is for the spacing in between the beams, and these are the deflection in between the curve. Okay, in between the curve, the movement in between the beams. So that's by the way. So just click on what okay, and that is okay. So you are feel free to check, because most case it might design with what, with Y20. So if you want to make all the reinforcement, maybe you want to make all the reinforcement to be what 16 mm, you can, if you have 20 mm, let's say you have 20 mm here, let's say you have 20 mm here, you just have to come and increase it and reduce to 16. So in this regard, it is 16. So just leave it. So you are feel free to check all of them, because in most cases some can design with 20 mm and some with 25 mm. So check. It's very, very necessary to check all of them one after the other. You have to check one after the other to see what happens. So in as much as you're doing this, you can actually try to pay more attention to the one you have multiple span. Okay, so let's just try to look at that. Okay, let's try to get to the interactive design. Double clicking. Okay, you can see we have all 3 systems. So let's keep on checking. So in this model, you can see that we have all 2y16. So which means this model is a stable model. You see, you can see the distance in between them. We have 4.4 meter, 3.6 meter, and the case may be. But in a situation whereby you're having a wider span like 6 meter, or the case may be, you might be having a higher reinforcement here and a higher numbers of the reinforcement. So for the purpose of this video, since we have not seen any one of that, let's just assume that they are all the same. But okay, when you're doing your own, please, when you're doing a real stick design, please try to do what, to check all of them, to make sure you check everything before then. So after that, we just do what, we just close this video, so we can see we're done with the beam. Okay, beam design. So the next thing now, which means after checking our beam, we're sure that our slab is okay. So what we need to do now is to go and design for our foundation. So to design your foundation, what we need to do, we just have to go to the foundation. So in this case, we are looking at how we can design a pad foundation, a pad footing to this. Okay, so subsequent video we can look at every other type of foundation, where we're looking at raft, where we're looking at strip, and we can look at a raft slab, as the case may be. Even pad foundation, we can also look at that. But in today's video, let's look at how we can just use a pad to support them. All right, to support this. So fully knowing that, now when you've got to your foundation, what you need to check is the bearing pressure, because you have to know the pressure of the soil on the building. Okay, in that design, because the first part we've already run analysis of the building and we're done with analysis of the building. We should check the column and we've checked the beam. So right here we're looking at the soil pressure. So when we want to design your foundation, you need to know the bearing capacity of the soil, right? The capacity at which the soil can be able to resist the pressure, the load that's coming upon the soil. Okay, because we have all load from different floors distributing down, to the foundation. So we're looking at what we are looking at 120 kilonewton per millimeter square, per meter square rather. So with this, we just have to now look at, okay, what will be our spacing? We know what will be our minimum depth of the foundation. Okay, so okay, let the minimum depth of this foundation be let's say 300. Let the minimum be 300. But this is not trying to say that it's going to be 200. It's trying to say let our minimum be 300 millimeter, so you can design with other footing as the design specified. Okay, so you can look at the spacing in between. This is the maximum spacing of the bar. So this is the maximum spacing in between each bar. So I want to make this the maximum to be 20. Okay, because of the height of the building. So you can also look at maybe your maximum should be 150, as the case may be, but I just want to keep it simple, which means it is not a priority that it must be this. Is just like the maximum. Okay, so you can still design with 100, with 120, or as the case may be, but we just want to keep it simple. And you can see every other rebars, okay, are already here. So what we need to do, we just have to click OK. So after clicking OK, we'll just come down to the footing. So when you're instructing your pad foundation, the pad foundation, it has to be inserted on the footing, okay, on the columns. So looking at the columns, that's where you insert your pad. So how do you do that? You do that by doing what? You can zoom in, click on the column, you right click. When you click on the column, you right click, then you go to what? Insert pad footing. Okay, if you're designing for pie, you can see insert pie cap. You design for the pie cap, you can see, then you can look at the draw patch for all of them and check, punching check if you are doing for other analysis. But since we are looking at how we can insert our part, so we just click on insert part footing here. So if you click on insert part footing, you wait for it to just load, and while it loads, it's going to give us a table whereby it has already designed for a favorable or a suitable design. You can see what we have. We have a footing here of 1300 millimeter by 1200 millimeter. But when you have something like this, we have to make it a square footing. Okay, so if we have to make it a square footing, so when you have something like this, we have to use the higher figure to put it. We have to reduce this, otherwise it's going to fail. Like here, if you look at it, if you reduce this, you can see that it does what? It has failed. You can see the red color here has changed to red. So what we need to do is just to make it at what? At 1.3 meter. Then we increase this to be 1.3. So everything is going to be 1300 by 1300 millimeter, or 1.3 meter. All right. So the centricity is pays at 0 because we are taking this. Okay, you can see we have different eccentricity whereby you're designing your part to be in what? At the columns to be at one edge or at the middle of this point. You can see different eccentricity as the case may be, but this is what center to center. That is why we have this at the middle. Okay, if I decide to choose this now, it's going to push it to this end. If I decide to push this, it's going to push it to this end. Any of this that I take is going to follow the eccentricity. But in all of this, the eccentricity, the design for this is quite different. That's why you see this is failing, because of what? Share value over here. So I have to provide for the centricity here. All right, so in that situation, we just want to keep this simple, so we just make it simple, so that as we place it at the middle, what happens is it's going to share all the stress, distribute them to both side of all the stress is going to be distributed evenly across the middle of the pad, right? So you can see that it's passed with this, and a minimum of what? 300. So we can even say, okay, let's add more footing. If that is what you want, you can say you want to increase it. But in this situation, let's just look at it 300 because I want to keep it. If I look at the structure, the square area is small, so another the load that is coming is small. That's why I have to say minimum should be what 300 depth of the footing, and you can see it pass with this. So the next thing we're going to check, these are all when you look at pedestal, we're not adding a pedestal to that, okay? So, but if you're in a situation whereby you're adding a pedestal, then you can do that, okay? You're adding a pedestal. A pedestal is just like when you have something, you can look at the footing, okay? Then you have a pedestal and you have the column. This is the column and this is the pedestal supporting the column. But we are not adding that, okay? If you are doing that, you just have to specify the length and the height of the pedestal, all right, and the size of it. So I'm not doing that. I have to keep it simple. Then moving down to analysis. The analysis is where you look at the unit of the soil and the bearing capacity. You can see what we have here, right? So you can see for this we'll provide 120 and 150 is adequate for this design, which means it is what over okay, all right, it's very much okay for this. So in doing that, what we need to do, because these are all materials, so we'll look at the option. This option now talks about the spacing requirement, which we've already taken, and these are for the columns, but we're not doing that. So we'll just go straight to the rear bar because that is what concerns what we are designing, okay? So when we come to the rear bar now, if you look at the 3D, if you look at the 3D, if you look at the 3D version of it, okay, you can see even on the 3D, specify how your column should be tied because a lot of mistake happen on site where you're tying your link, you're not knotting them different positions. So you have to follow the position by which is provided here, all right? So you can see where we have top and bottom, but since it's a single footing, I might not consider having a top and bottom. I might consider having just a bottom, okay? So I'll just untick the top and I'll untick the double top, okay? Just untick the double top, all right? And I'll tick the sidebar because I don't want a sidebar to run. I just need a single footing. And if single footing is passing with what? Y16. So let's just change the size of the bar to see if 12 will be okay. All right, so you're going to look at the design here. So you're changing, look at the spacing, and you're looking at the area required and the area provided over here. See that even the white ware for the foundation is okay, all right? The white ware for the foundation from the area provided, area required, and area provided, you can see is higher, all right, for both side of the eccentricity. So if we look at 12 mm here, look at the area required, and this is area provided and area required. So this area required is 4 in this segment. In the direction 2, what we'll have direction x direction, we have 444.79, all right, as required, and this is what provided. So it's super okay, and design is what, so design successful. So with this size of the reinforcement, 1300 by 1300 reinforcement is perfectly okay for this design. So what we need to do here now, you can just come and click OK. So click OK. Once you click OK, it's going to what? Introduce the part. So we'll do the same thing to all of them, okay? So you just go back, you click on it, you right click, and you go to what? Insert pad. So insert pad is going to what? Distribute. Now if you look at what we have here, this now, all this, we're not supposed to have the same footing, okay? If we're not have, unless we're having an even load, a load distributing almost equally, okay? But in this situation now, you can see in this area, the first one will have 1.3, 1300, and now we have 1800 over here, okay? So just want to keep a single footing, right? The same thing over here. Just want to keep a single footing. All right, for them, that is okay. I'll just say okay. You click the next one, you right click, you locate insert part footing, the same vein. It's just going to analyze it and design it immediately. So you can see here we'll have the same footing. So we'll just increase this to give us 1/8 by 1/8. I'll go back to rebar and we'll change this to 16 to 12 rather, from 16 to 12. Check the minimum reinforcement and it's okay. But if you still prefer to be in 16, then that is absolutely okay. All right. So what we just need to do is just to do the same thing. So for this, we have 1,200. So we'll go back to the rebar and we'll change them to what? To Y12. To Y12. So that's the same procedure. What we are going to do, then we'll take off this. We're going to repeat the same procedure for all of them. Going to repeat the same procedure for all of them. Now all this will be okay because they're all distance, but let's look at what we have over here because of how close this column is. So we'll just right click and we'll say insert what? Part foundation. So insert what? Part foundation. We'll now wait for it to load. We have 1 meter, which is not bad, and what will change the size of it. Okay, and we are changing the size of it. You're looking at the area provided and the area required, okay, for the reinforcement, because you're providing 5 diameter, 12 at this spacing, okay, provided. You can see this is the one provided and this is the one required, okay. This is the one required and this is the one provided. So everything is spacing 5 here, this is it, okay. So we have 5, 6, 5, 8, 7 against 3, 6, 5, okay. So that is okay, and we'll click okay. Go to the next one. Just want to check if there will be overlapping. If there's overlapping, then there's a way we're going to do a combined footing along that area. All right, we're going to do a combined footing along that area. Along such area, we will have that. You can see now, if you look at now, you can see the overlapping. We've not done this, and it is overlapping already. So what do we do? I'm going to take these three columns, and we want to make this one. Let's check this if this is going to be what part of them, so we know how many we are going to be combining. All right, so just need to know the size. 1.1. okay, just want to increase to be 1.2 so that they will be all equal. 1.2 1.2 will just go instead of having 1.2 1.1. okay, so that is by the way, and we'll say okay. So let's see what happens here. You can see this is different. Okay, this is quite different. So that being the case, let's take off this. So I'm going to delete the part footing. So we're going to highlight these three, because we've highlighted these three. I click on it and I drag and I highlight them, or you press your control and you click one after the other by using your control. Then you right click and you locate combine, insert combine part footing. Okay, now we don't want to do what? Insert part footing, because we're not doing a single part footing. Now we're doing what? We're doing what? A combined footing. So we have multiple columns, so we want to combine them. So in that case, what we just do is just to click on what? Click on combine part footing. So when you click on combine part footing, so it's going to show us the design for all the area, right? So I don't want it to be in this part so that it's not going to overlap with this. So I'm going to reduce over here and increase my footing here. Let's say 1.8, 2.8 by 1.8. Is that okay? Let's go again. Let's say by 1.6 or probably 1.5. Okay, that is switching. Let's say 1.6, and 1.6 should be okay. Then we'll go on the rebar. We'll change this to be, because of the double footing, let's leave it to be what? Because of the combined footing, we're going to use 16 rebars to detail it, and we'll leave the sidebar to be 12, right? So we'll go back to the graphics and let's increase this to be 3 meter. So bring it back 1.8 by this. So let's see what we got here. No. This is not good. It's not looking good. I have to increase it more. So we'll click on it. I'll go to property. You click and you go to property so that you can still get this. You're not repeating it again. So let's increase, because you can see it overlapping here. And one thing about proto structure has a way of representing a combined footing. It doesn't shows you the three columns as is going to do in a single footing. In a single footing where it's going to show you individual columns. So here it's going to show you a rectangular structure showing you that this is the perimeter of the column. So where the column exists. So you can see the distance where we have here. So that is by the way. So after doing this, you can see that the perimeter where we have now, the column is now inside. So if you click OK, you can see it's going to spring out with this. So by this doing, that is okay. So we can go to the next one. We'll do the same method. We're going to do the same thing. We have 2 meter. So let's increase to 1.2 by 1.2. That will be okay. 2.1 by 2.1. So that will be okay. Since it's a single footing, let's change it to 12. It's a single footing, let's change it to 12, and let's remove the top bar and the side rebar. All right. These are the side runner for the sidebar, and these are the top bar, right? So just want to be single, so just click OK, and it's going to appear over there. Although it's closed, but we just have to let that go. So we'll do the same thing. We'll just repeat the same process for all of them, right? So now we'll successfully finish this whole part. Now remaining this whole section, right? So if you look at this, if we try, because of how close it is, if we try to put it, it's going to be overlap, right? So because of how close it is, so what we just need to do is just to click on both of them, because we want to make this combined footing because of how close it is. Because if we put this, it's going to, the part footing is going to, the footing are going to overlap. So instead, let's just repeat the same procedure we have here, you know, by making a combined footing. So click on both columns, and we'll just right click. When you right click, you go to insert part footing, you click on it. So when you click on it, you wait a bit for it to calculate load. So in just a single click, it's going to do what? Analyze and calculate the load. So before we achieve this, all this is going to be what? Achieved by it calculating the load and all that. So you just have to look at it. If it's what you want to adjust, like what I've been doing, you can adjust it and check all your area and check the design, right? In as much as the design is provided, you have to check the area required against the area provided, because when the area required and is very close to the area provided, then you need to upgrade the reinforcement or increase the section of the footing, okay, so that you'll be in a safe condition. But now you can see we have 2010.62 against, that is provided, against what is required. You can see we have 877.5 is what is required, is the required area of this footing, but what we have is against it, okay? So but I don't want to truncate it. This is perfect and okay for the design, all right? So that is by the way. And if I look at my rebar, I want to keep it the same, so I can just come here, because we have a double footing, so we can change here to be what? 16 mm, all right? 16 mm, and the size to be what? The side rebar, the side runners to be what? 12 mm, okay? So that by the, so after this, we just click on OK, and it's going to what? Give us the footing. So we'll repeat the same procedure here by clicking the first one, and we'll click the second, we'll right click, we'll go back to what? Combined footing. Mind you, this is for a single footing, and this is what for when you're having a combined footing, all right? So click on the combined footing. Don't mistake them or be confused about it too. If you're not getting it, please, it's a video. You can go do well by going back and try to watch. And please, if you've not subscribed to the channel, please do well to subscribe. It will help us grow. And comment and share your view. We always appreciate all your effort, so please and please, want you guys to increase or help us by increasing our like to what? 100 like. We just want 100 like, because almost at the end of the video. So you can see we just have to what? Increase it, because what I have is what? I have 1900. So I just have to increase, and we'll come back here to the top, and we'll go what? We'll click on 16, and we'll go the next one to 16. So I want to leave this on this way. So with this size of footing, I just say what? Okay. So when I have this, you can see all footing is what? Analyzed. So go to the 3D. Let's go to the 3D and check. So you can see all footing is duly analyzed, and check. So we have come to the end of this tutorial, this part 2 tutorial. So in our part 3, we'll be revealing how you're going to what? Export your drawing, and how you're going to prepare your reports, okay? So please, I want you to give us a thumb up and a like, and thanks and bye for now.